Hi everyone, my name is Brandon and my partner Wen Yi is going to present our simulation and credibility computer-based test in this video. Next. The objective of our CBT. The industry that we chose to work in is the life insurance industry, and in particular the interest rate before and after reserving. Reserve is a fund set aside by an insurance company to pay out future claims that have not yet been settled. The reserve is used to pay policyholders who have filed or are expected to file legitimate claims on their policies. As we have learned from past modules, after receiving the premium and deducting the expenses and death survival benefit costs, the remaining funds will be put into the reserve. Insurance companies will actually invest the reserves to gain some profit, or in another sense, increase the value of the reserves so when policyholders do file a claim, the company will have more money in the reserves. The insurance company will invest in two instances in this process, once before deducting the death and survival benefit, and once after the cumulative reserve. So what do insurance company usually invest in? Insurance company usually invest in government bonds, fixed income securities, real estate, and others. For this CBT, we are choosing to focus on the interest rate of the government bond. In this CBT, we will be using a 20-year endowment life insurance as our product. The 20-year endowment life insurance is a type of life insurance that covers the death of the policyholders for 20 years starting from the age they buy the policy, and also a survival benefit if the policyholder survives past the 20 years. We use some theories and formulas from our past modules such as LC1 and LC2 to help visualize our simulated data. In our worksheet, we presented the data for age 0, 10, 20, 30, all the way to 80, which includes all the data used after receiving the policyholder's premium that my partner Wenyi will further elaborate on. The reason why we stop at 80 is because beyond 80 years old, the mortality rate increases exponentially. Therefore, the insurance company is almost certain to lose money if they were to provide this insurance to people of that age group. Next. First off, to make things clear, in this assignment, we made necessary assumptions in this simulation model to ensure a greater understandability and smoothness of the model. The first assumption is the death and survival benefit are 125% of the total premium paid. This is because the death and survival benefit should be higher than the total amount of premium paid. Secondly, the first year reserve is 80% of the first year premium. Third, each year's reserve includes a 4% compounding inflation rate on the first year reserve. Fourth, we do not consider the possibility of surrendering. And fifth, the interest rate is set in the range of 2 to 5% based on a trusted source that forecasts the future year's interest rate. It should also be noted that currently the average interest rate is around 3 to 4%. As we can see from the graph above, that is a real-time graph showing our interest rate of the government bond as of 12 December 2023, and the graph below shows us the Malaysia government bonds interest rate, forecasted interest rate for the next 30 years. All right. It should, to the Excel please. It should also be noted that currently the average interest rate is around 3 to 4%. We also set some restrictions on the model to provide a clear picture to our viewers. For example, the annual premium is set at 1,000. The age is set at an interval of 10, starting from age 0, and the assumed gender would be male. These restrictions could be changed as per our client's requirements, but we are only using this set of restrictions as a sample of our work. Next, I'll pass it to Wenyi.
Okay, now I would like to explain the output of the simulation process with using the assumption that Brandon explained it just now. Before we start our calculation on profit vector for each simulated cases, we have to calculate the reserve at the end of each year based on a premium amount of 1,000 per year. Based on our assumption, the reserve amount for the first year is 80% of the premium, which is 800, and the increased amount of reserve every year is with a 4% inflation rate, which mean the second year increase amount in the reserve is 832, which calculate by 800 multiply 1.04, and the third year increase amount is 832 multiplied by 1.04 equals to 899.8912, and so on. After calculating the increase in reserve, we accumulate year by year to obtain the amount of reserve at the end of each year. For the 20 year, the reserve amount should be 0 since it is the end of the insurance period. After that, by looking at this table, we can know the profit signature of 0 years old male, 20 years endowment insurance for each year. In this table, the age and year column represent the policyholder age in the corresponding year. The premium column represents the premium amount paid by policyholder each year with the amount of 1,000. And the expenses column represents the renewal expenses for the insurance with 50. And next, the interest rate in this simulation form, which random interest rate between 2 to 5%. The interest column shows the interest earned by the company in its investment with the simulated interest rate. In addition, the debt cost equals to the debt benefit multiply the mortality rate of the policyholder at the corresponding year. Maturity costs are incurred only in year 20 because survival benefit will be paid at the end of the policy period if the policyholder is still alive. The maturity cost is calculated by the survival benefit multiplies survival probability from year 19 to 20. After that, we sum all the premium, expenses, interest, debt costs, and maturity costs each year. We can get an expected annual cash flow for 20 years. To get the profit vector for each year, we must know the increase in reserve and interest on reserve. Reserve at the end of year multiplied by the survival rate to the corresponding year and minus reserve at the beginning of the year equals to the increase in reserve. Since at the first year don't have reserve at the beginning of the year, the formula for the first year is reserve at the end of the year multiplied by the survival rate only. And for the last year, it don't have reserve at the end of the year, therefore it equals to the negative of the reserve at the beginning of the year. Next, we need to calculate the interest reserve by multiplying reserve at the beginning of the year with the interest rate simulated. Lastly, the profit vector is expected cash flow minus increase in reserve and plus the interest on reserve. For each year, we must multiply the profit vector by survival rate from the current age of the policyholder to the corresponding beginning of the year, which is t minus 1 p current age. To get the survival rate from the current age to the corresponding beginning of the year, we can multiply the previous t minus 1 p current age with the survival rate for the previous age. For the first year, the policyholder will definitely survive when they buy the endowment insurance. Therefore, the probability for the first year is 1. At the end, we can get the profit signature by multiplying the profit vector with the survival rate. In order to understand the relationship between this interest rate simulation and net present value, we must get the average interest rate and NPV of this 20-year endowment insurance policy. The average interest rate over the 20 years is calculated by dividing the sum of the interest rate over the 20 year by 20. To generate the NPV for these cases, we use the NPV formula in Excel with a discount rate of 10%. Lastly, we will get the average interest and NPV for the first simulation In order to achieve our objective, we increase the sample size to 500 and repeat the same step explained 500 times. The reason why we choose 500 as the sample size is to make the relationship between the average interest and NPV show a normal distribution, which let the result of the simulation model more reliable and logical. If the sample size is too small, there will be many potential errors in the analysis result. A sample size of 500 is enough to reduce the error in the result and make them closer to real-life example. In this sheet, it shows the output of 500 sample for age 0 mil on 20-year endowment insurance policy. Next, to generate the output of 500 sample for each age we select in this simulation model, we duplicate the sheet 8 more times and change the age to 10, 20, 30, 40, 50, 60, 70, 80. After we generated all the output, for visual convenience, we create a table showing the average interest rate and NPV for all 500 cases at different ages. In the table, the whole NPV column shows a result with a positive value, represent the corresponding age in this 1000 premium based 20-year endowment insurance policy will bring profit to the insurance companies. On the contrary, if the entire NPV column shows a negative result, it means that the corresponding age in this policy with a premium of 1000 will cause the insurance company to suffer losses. This table shows that men aged 0, 10, 20, and 40 will bring profit to the insurance company, and men aged 60, 70, and 80 will bring losses to the company. For the age 50 column, it has positive and negative NPV, and it changes randomly. The net present value of this policy is calculated on an individual basis, so judging whether to provide this 20-year endowment policy with a premium of 1000 for a 50 years old man depends on the current interest rate. To make the output visualized, we generate the scatter plot with trend line of linear for average interest rate and NPV, and this graph for age 10, and this is for age 20, 30, and so on. After have a look with all the graph, we can significantly found that 500 sample size of the interest rate and NPV shows a normal distributed. The higher the interest rate, the higher the investment income. So as interest rate increase, NPV also increases. Therefore, the trend line in the graph show an upward trend by looking to the graph for age 50. By looking to the graph of age 50, the trend line passes through x-axis, which means that at a certain interest rate, the NPV will be 0. In order for the NPV to have a higher possibility of being positive, the interest rate should be higher than the interest rate at the x-intercept point. The linear formula is generated by Excel automatically. In order to obtain the interest rate for judgment, we can use the linear function y equals to mx plus c. To get the value of the slope m, we can use the linear's function in Excel and insert the data we get, and the constant c we calculating using the average of y minus the slope times the average of x. The interest rate of achieved non-negative NPV is at the x-intercept point, which y equals to 0. Therefore, we sub x and y equals to 0 into the linear function. We can get the value of the interest rate for non-negative NPV, assuming that there are no serious emergency that will affect the interest rate, such as COVID-19, the interest rate required for user aged 0 to 40 to get a positive net present value is lower than normal, and it's therefore judged to be profitable for the company. A 50 years old man would need a current interest rate to be higher than 3.8395% to be profitable for the insurance company. Users at age 60 to 80 years old require the interest rate that are higher than the normal range, so it is judged that they will bring losses to the insurance company. And now I'll pass it to Brandon.
Next, I'll talk about the financial challenge that the insurance company will face. The financial challenge that the insurance companies face in this scenario is the uncertainty in costs incurred and also the uncertainty of the net present value of the product due to government bonds interest rate fluctuations. The factors that could affect the interest rate are inflation and also the economic performance of the country. In this CBT, we are only considering government bonds interest rate as the factor that could affect the net present value of the insurance product in 20 years. So why is the net present value so important to the company? The NPV in layman term would be the profitability of the product, and management use the NPV to decide if the product would be worth to invest or the product should be avoided. Due to the uncertainty and fluctuations of the interest rate, the company is unable to forecast the NPV of the product for the upcoming years, making it difficult to plan for the company's financials. Therefore, by using simulation, we are planning to be able to forecast the NPV of the 20-year endowment life insurance so that the company can estimate their profit signature throughout the 20 years and also to ensure they mitigate as much losses as possible when this product hits the market. Hence, the company can have a bigger picture of their expected profits. Thus, decision making and financial planning can be done with greater ease by the management of the company. Next slide. Our clients mainly consist of life insurance companies that are selling or planning to sell endowment insurance. Therefore, we are providing two proposals for our clients. One of them is to get our client's existing database and plug it into our simulation model. To find the perfect fit for both our clients and our client's client, we will obtain policyholders' information such as their age and income from the insurance company and also the insurance company's budget to obtain a value for the premium, which balances out between the needs of both the policyholders and the insurance company. The interest rate would also change based on the premium. For example, if the premium is 500, then the interest rate would change accordingly due to the simulated process. As we can see, after changing the premium to 500, the interest rate for the age 50 has increased past the normal range of 3 to 4%. Hence, this would mean that the insurance company should not accept clients that are age 50 and above if the premium paid is only 500. Back to the slide, please. The other approach that we are providing is to present our clients with the baseline premium for ages 0, 10, 20, 30, 40, and 50. This means that the premium we suggest to the insurance company is the minimum premium that should be charged by the insurance company to obtain a positive NPV for the 20-year endowment life insurance. The insurance companies can follow these guidelines when quoting their clients to ensure a positive NPV can be acquired. The reason why we did not include the age of 60 and beyond is because the mortality probabilities for these age groups are too high and the NPV will always turn out to be negative no matter how high the premiums are. Therefore, we would not suggest our clients to sell this insurance to people aged 50 and above. Back to the Excel sheet. As we can see, the highlighted column is the suggested premium column. The minimum premium required to have a positive NPV for each age can be shown in the suggested premium column. So for example, for age 0, the suggested premium is 295. So that would mean that the policyholder must at least pay a premium of 295 per annum for them to participate in this policy. Right, back to the slide. Next. To close things off, let's do a quick recap on what we have talked about for this video on our assignment. We simulated the interest rate of government bonds based on a trusted source that forecasts the interest rates for the next 20 years, which is in the range of 2 to 5%. Our sample product is a 20-year endowment life insurance, which is a type of life insurance that has two components. One, a death benefit if the policyholder dies within 20 years of buying the insurance, and the other, which is a survival benefit if the policyholder survives past 20 years from the date of issue. We use a set of random generated data to generate the interest rate between the range to simulate the performance of the net present value of the endowment insurance to give our clients, which are the insurance companies, a picture of the NPV of a 20-year endowment life insurance based on the amount of premium set and also the interest rate of government bonds. By using simulation, we provide our clients with a fast and somewhat accurate data that can help the insurance company with the decision-making process. Of the two main solutions that we provide, the first one is the minimum premium required that should be quoted by the insurance company in order to obtain a positive NPV. The second solution that we provide is the minimum interest rate required for the product to have a positive NPV. With that said, this would be all from my partner and I for this video. The disclaimer is everything in the Excel is automated, and change in any of the values would be changing the whole Excel sheet. Therefore, our clients can use it to their advantage to change the values of the premium and all the parameters in the assignment. We hope that our solution and expertise are able to contribute to the problems that insurance companies are facing. And if you guys have any further questions, please do drop a comment and we would get back to you as soon as possible. Once again, thank you for watching and please have a good day ahead.